Hi, welcome. In this video, we will solve problem maximum subarray on greedy asked by companies like LinkedIn, Microsoft, Amazon, Adobe. Let's check out this problem maximum subarray. This is the most common question in DSA that is asked in interviews. Okay, you can get this question in many interviews. If you are aiming for a company that is between 8 to 12 or 14 LPA, you can expect these types of questions. Why this is most common? Because this is straightforward, right? Very simple problem statement, easy to understand, but there are different things that an interviewer can discuss in this problem. Okay, there are different approaches, different methods to solve this problem. Okay, so let's understand it and let's understand the problem statement, and then we will see how we are getting the output from the input. So we have given an integer array nums and find the subarray with the largest sum and return its sum. So what is subarray? Yes, we have discussed about the subarrays concept. Okay, that means subarray are the continuous set of elements. Okay, continuous set of elements like -2. This is one subarray, and if I say -2, 1, comma -3, this is also subarray. Empty set, this is also one subarray, right? And if I'm taking a complete array, that is also a subarray. This is not a subarray, right? -2, 1, and if I'm taking suppose -1. Okay, so this is a subsequence, right? Because you are taking this element, and then you are taking this element, you are leaving this element. Okay, it should be continuous set of elements. So continuous set of elements. And why, like, basically what are arrays? Arrays are contiguous memory locations, right? So arrays is a contiguous set of memory locations. So subarray will be again, it will be a contiguous part of a contiguous memory location. Okay. So if I say this is a subarray, so no, this is not a subarray. This is a subsequence. Okay. Now the subarray that we need to find should have the largest sum. Okay. And we need to return its sum. Okay, so let's understand the problem statement. So let me just erase all these things. Now let's see. So I want a subarray with the maximum sum, right? And if you can see, we are getting the maximum sum as 6. So if you can see, if I take 4 minus 1, 2 and 1, what will be the total sum? That is 6, right? So this is the my subarray with 4 minus 1, 2 and 1, and this is the largest sum that I can get in the subarray. If you take -3, your sum will decrease, right? And if you go over here, right, then still your sum will decrease. If you move here, then your sum will decrease. You can see -5, -3 is here. Okay, so this is the largest sum. Okay, that is 6. Here, what is the largest sum? So if you take the complete array, okay, 5, 4 minus 1, 7, 8, this you will get 23. That is the answer. And this is your subarray, right, with largest sum. So let's see how we'll solve this problem. I hope you got the understanding how we are getting the largest sum. Okay, and now we will see how we can solve this problem. So we will discuss the brute force, the better and the optimal approach, right? All the three approaches. And in the interview, you should discuss. Oh, basically, the interviewer wants you to analyze, to think. He wants to check how you are thinking, what are the thought process. Okay. So basically, if you make it more pure or more, what I will say that more true, that you are thinking that this is your thought process, this is how your mind works. Okay. It will be very good. Okay. So we will discuss the brute force, that first approach that comes to your mind when you will see this question. Okay. So this is my nums array and I want the maximum sum. So what is your first approach? How you will solve this problem? So basically what I will do, what is my goal of this question? Okay. What is the goal of the question? That I want a maximum sum of the subarray, right? Maximum sum of subarray. So what I will do, I will find out all the possible subarrays, right? So what will be my goal? That I will generate all subarrays. Okay, so if I generate all subarrays, it will be 1 minus 2, then minus 2 comma 1, right? Minus 2 1 minus 3. What I will do, I will take the sum of it, right? So 1 will be minus 2, then minus 2 plus 1, that will be minus 1, minus 2 plus 1 minus 3, that will be minus 4, and so on, right? I will generate all the possible subarrays, and eventually I will get the result, because one of the sum will be maximum. I will simply, when generating, I will simply check the maximum sum, and then the maximum sum will be my answer, right? So this will be your approach one. And like how you will do it, so basically one thing is you can generate the subarray, then take it out the sum, then the time complexity will be very high. So we are not discussing that thing, that generating all the subarrays, then figuring out the sum, and then we will directly calculate the sum. So basically what will be my approach, I will simply start my for loop, and that will, I will start from 0, and this will go till n minus 1. Okay, and then I will start one more loop that will start from j equals to I. Okay, and it will go again till n minus 1. Okay, and what I will do, I will simply do sum plus equals to, here we have nums, so I will say nums of j, right? And now I am doing the sum, so I will simply check if anytime my sum is greater than maximum. So here you can define your max as minus infinity. Okay, so if sum is greater than max, then what will be the, what you will do, you will simply update the max with sum, and this is how you will generate the result, right? So this is one way of solving this question, by generating all possible subarrays. Okay, again, like I have said, like there is one method that generating all the possible subarray, then calculating the sum, then the time complexity will be big of n cube. But we are not discussing, because right, this is not, that was not a, like that is a very very brute force, right? Very brute force, and it is also not intuitive. So if you are solving first problem, right, this will be the one intuitive method that you will come up with. So what will be the time complexity of this approach? So this is running for n times, this is running from I to n times. Okay, so not completely n, but yes, I to n times. If I take total iterations, uh, so like it will be around something of sum of natural numbers. So like how I will say that this is in the first time it will run for n minus 1 time. Then in the next time, when I will be I plus plus j plus plus, it will run for n minus 2 times, and so on. Then it will run by 3 times, 2 times, and 1 times. What is this sum? This is sum of natural numbers. If I say it will be something as n into n minus 1 by 2, that is n square minus n by 2, and that is, if I take the higher term, it will be big O of n square. So the time complexity of this approach will be big O of n square, and there will be no space complexity, that is constant, because we are not taking any extra space. Yes, so this is one of the method. Okay, how we can solve this, basically generating all the subarrays, finding all the possible sum. Okay, and we can get the answer. But now interview won't be happy with it, right? Because interview also know, like big O of n square is not a good solution, you need to improve the time complexity. Okay, so how you can improve the time complexity? Again, you have this nums of array. Okay, this is array. Now how you can improve the time complexity here? So let's see, let's understand again, what is the goal? The goal is maximum sum. All right, I want to find a maximum sum. Okay, and for this problems, okay, we will apply one of the famous algorithm, that is Kadane's algorithm. Okay, so we will solve this with Kadane's algorithm. Basically, this is Kadane's algorithm. So how this is work and what is the intuition, we will discuss everything, right? How the intuition comes. So let's discuss, like if you are a student, how you will develop the approach, okay, how you will come with the Kadane's algorithm. So that is very simple. This is our array, and again my goal is to find the maximum sum, right? So what I am thinking, that I will take the sum. Suppose I am taking one sum variable and I am starting with -2. Now think here, you are starting with -2, okay? If you are taking -2 and moving with forward, will this -2 help to increase your sum? Suppose, what will be the possibility of the next number? It can be a positive number, maybe a +9, or it can be a negative number, maybe -9. Will taking -2, taking a negative number, will you help you in any how? Suppose if you directly start from +9, you have a sum of +9, okay? If you directly start from a -9, suppose our next number is -9, so you will have a -9. But if you are taking -2, what will be your sum? -2 plus 9, that will be +7, again lesser than +9. If you are taking -2 plus -9, it will be -11, and which is also lesser than -9, right? -11 is not greater than -9, no. Okay, so these both are lesser values. So taking a number, mm, taking a number which is less than 0, if I say, which is negative, which is not contributing in my maximum sum, should I take it? This is the intuition. Should I take it or leave it? Start with a new number. So yes, I should start with a new number. So what we will do, we won't take -2, okay? We will start with a new number. Let's take +1, okay? So basically, like, you got the sum, right? You -2 and you checked it, like, is your sum is less than 0? And yes, it is. So what you are doing, you are again starting your sum with 0, okay? Simply fresh. So now sum is 0. Now what you are taking, you are taking the next element, that is 1, okay? Now 1, which is greater than 0. So what you will do, you will update, you will take one maximum, okay? Suppose your maximum start with -infinity, so -infinity and 1, which is greater, 1, so you will update with 1, okay? Now again 1, you will move to the next element, 1 with -3, so 1 minus 3 will give you -2. Again sum is less than 0. Is it a good to take this number -2? Is it too good to move with -2 as a sum? No, I will start with 0 again. So I will start with 0 again, okay? And again my maximum is 1, like the maximum sum I got till here, that is 1, okay? Now again I will move with 4, okay? So what I will do, I will add in my sum. So let me remove this. I will add in my sum 4. Is 4 is less than 0? No, 4 is greater than 0. So what I will do, I will update in my max. So I will update 1 and 4. So my maximum will be updated by 4. And what I will do, I will simply move it. Now 4 plus -1. So 4 plus -1, it is 3. It's still a positive number, right? You can go with it. You can go with it. So yes, we will go and I will check, is it greater than maximum? No, it is not. So let's simply move. So I will check. Now I am getting new number 2. So I will add 2. So 3 plus 2, 5. Okay. Again, it is not less than 0. So no need to make it 0. Again, I will check, is it greater than maximum? Yes, it is. So I will update my maximum with 5. Again, I will move to a new number, that is 1. So 5 plus 1, that is 6. Okay. Again, greater than 0, I will update with maximum. Okay. So my maximum will update to 6. Now I will take the next number, that is -5. Okay. So if I am taking -5, what will be my new sum? That is 1. Is still greater than 0. Yes, right. Still it is greater than 0. So what I will do, I will check that yes, it is greater than 0, but not greater than my maximum. So my maximum will be 6. Okay. Again, I will check new number, that is 4. So 1 plus 4, what is the new number? That is 5. Okay. So is my maximum is greater than, like, maximum is greater than sum? Yes, it is. So 6 is my maximum. And that's it. You are end of this loop. So the maximum number that you are getting here is 6, the maximum sum, right? So this is the right intuition. Basically, you are taking a number and you are finding if your sum is less than 0. So why we are going with that sum? Why we are not doing sum is equals to 0, right? So basically, whenever you are getting sum less than 0, you will simply make it 0, okay, and you will move with it. So now let's see a small pseudo code how we will solve this problem, right? So I will simply run a loop that will start from 0 till n minus 1, the length, complete length. And what I will do, I will simply sum plus equals to nums of I. Basically, I will add it. Okay, I will add it. I will check, like once I add it, is my sum is greater than maximum? Okay, because even a negative number can be greater than minus infinity. So I will check first. I will check if it is greater. Yes, it is greater. I will update with my maximum equals to sum. And in the last, I will check is my sum is less than 0. And yes, if it is, so let's start with sum equals to 0. Okay. We don't need to take the negative number moving forward. We will simply put it sum equals to 0. So then you will add a new number again and again, again and again. And in the last, you need to return maximum. So for what will be the time complexity of this approach? So here you are simply running a loop that is running till n times. So time complexity will be big of n only, right? So time complexity of this approach will be big O of n, okay? And space complexity will be big O of 1 constant, okay? Because we are not taking any extra space here, okay? Now in this question, your interviewer can ask different varieties. That's why this is a good problem. So varieties like this, you got a maximum sum that is 6, okay? So one variation he wants to ask, okay, I am happy with maximum sum, but I want the maximum size of the subarray, right? Basically my size of the subarray. So you are getting 6. What is the size of the subarray of 6? Okay, so what is your subarray that is giving you 6? Basically this is your subarray from 4 minus 1 to 1. Okay, this is your subarray if I say. So what you will do to calculate this, right? So basically, whenever you are starting a new sum, right? Whenever sum is less than 0, you are starting a new sum. Okay. Or basically, whenever sum is 0, you are starting from it, right? You are taking a number from it, right? Whenever your sum is 0. So what I will do, I will put one condition. If anytime, if my sum is 0, that means I am starting from that position, right? So I can simply say my start position, okay? Whatever the I is, I am starting from that position, okay? And whenever I am updating my maximum, I will calculate the length. So how you will calculate the length? Basically your current I, whatever the I is, and your previous start, I minus start plus 1, this will be your length. So you will store the length and you can return the length as well. So basically whenever your sum is 0, that means that's a new starting point. Okay. So like here I have started from 1. So this is my starting point. Okay. Here I have started from 4. So this is my starting point. So whenever my sum is 0, I am starting from there. And whenever I am updating, that means I got some maximum value, right? Like here I got 4, I got 5. So I will update length. Length will be I minus start plus 1. Okay. So yeah, this is how we can solve it. In the next video, I will tell you the complete implementation of this problem. Okay. And in the next video, just after this video, we will see the dry run of this code. Okay. So again, please go through this problem and remember the intuition. What is the intuition? The simple thing is whenever your sum is getting less than 0, why you are going with that sum, make it sum 0. Start with the, okay. So yeah, we'll see you in the next video.